Welcome to Across the Globe. Today we will learn about cross-validation techniques. Cross-validation is a technique utilized to evaluate and generalize the predictive capabilities of a model by assessing its performance on unseen data. This is crucial in ensuring the model's effectiveness in making accurate predictions for new data beyond the training set. One prevalent approach to cross-validation is k-fold cross-validation, where the dataset is divided into k subsets. The model is trained on K1 subsets and validated on the remaining subset in each iteration. This process helps to gauge the model's consistency in predicting diverse datasets. For instance, in a scenario where a machine learning model is developed to predict housing prices, k-fold cross-validation ensures that the model can make reliable predictions for different neighborhoods and housing types. K-fold cross-validation is a technique used to assess the performance of a machine learning model. The data is partitioned into k subsets or folds. The model is trained on K1 folds and tested on the remaining fold. This process is repeated k times, with each fold acting as the test set once. The final performance metric is calculated by averaging the metric obtained in each iteration. For example, in a 5-fold cross-validation, the data is divided into 5 equal parts. The model is trained on 4 parts and tested on the remaining 1, repeated 5 times. Finally, the average performance metric is computed to evaluate the model's effectiveness. To evaluate the performance of a logistic regression model using cross-validation, you can follow these steps in Python. 1. Import necessary libraries. scikit-learn.modelselection.kfold for creating cross-validation folds. scikit-learn.modelselection cross-val score for calculating cross-validation scores. scikit-learn.linearmodel.logistic regression for creating a logistic regression model. 2. Define the number of folds for cross-validation using kfold, e.g., kf equals kfold n splits equals 5 for 5-fold cross-validation. 3. Create an instance of the logistic regression model, model equals logistic regression. 4. Calculate cross-validated accuracy scores using cross-val score by passing the model, training data, xtrain, ytrain, cross-validation iterator, cv equals kf. 5. Print the cross-validated accuracy scores to evaluate the model's performance. Example: Python from scikit-learn.modelselection import kfold.modelselection import cross-val score from scikit-learn.linearmodel import logistic regression kf equals kfold n splits equals 5 fold n splits equal 5 model equals logistic regression scores equals cross-val score and ytrain cv equals kf. Print cross-validated accuracy scores. Cross-validation is a technique used to estimate model performance more accurately than a single train test split by dividing the data into multiple subsets or folds. This helps reduce the risk of overfitting by using different test sets for validation and provides a more robust evaluation of the model's performance across various data subsets. For example, in a 5-fold cross-validation, the data is divided into 5 equal parts, and the model is trained and evaluated 5 times, each time using a different part as the test set. This process allows for a more comprehensive assessment of how well the model generalizes to unseen data. Cross-validation is essential for evaluating the performance and generalizability of predictive models. It involves dividing the data into k subsets and iteratively using each subset as a validation set, while the remaining subsets are used for training. By repeating this process for each subset and averaging the results, we obtain more reliable performance estimates compared to a single train test split. Using k-fold cross-validation helps in obtaining a more robust estimation of the model's performance and ensures that the model is not overfitting to a specific train test split. This technique is particularly useful when the dataset is limited or imbalanced. Incorporating cross-validation into the model evaluation process is crucial for obtaining accurate and unbiased performance metrics, ultimately helping in selecting the best model for deployment. An example scenario could be evaluating different machine learning algorithms on a dataset to determine which one performs best in terms of predictive, accuracy, and generalizability. Cross-validation is like practicing a presentation multiple times before the big event to ensure it goes smoothly. Just like how trying out different driving routes helps you understand the best way to reach your destination, cross-validation helps test different models to understand which one performs the best. It's like dividing a test preparation booklet into sections and completing each section to make sure you are ready for the entire exam. Similarly, in programming, cross-validation involves splitting the dataset into multiple subsets for testing the model's performance on each subset to ensure its accuracy and reliability. Hey, Code Conquerors, ready to level up? With scikit-learn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The presented Python code exemplifies the utilization of cross-validation techniques in evaluating a machine learning model using the renowned scikit-learn library. Initially, essential libraries such as k-fold, logistic regression, load iris, and accuracy score are imported to facilitate the cross-validation process. The iris dataset is loaded, consisting of feature data X and target labels Y. By initializing a k-fold cross-validation splitter, KF, with 5 splits, the dataset is partitioned for training and testing subsets. A logistic regression model is instantiated to be trained and tested during the cross-validation process. Subsequently, the cross-validation process begins, iterating over each fold generated by k-fold. The model is trained on the training data within the fold, and then predictions are made on the test data. The accuracy scores for each fold are computed, contributing to an accuracy score list, ACC scores. Following the completion of all folds, the average accuracy score is determined by calculating the total sum of accuracy scores and dividing it by the number of folds. Finally, the average accuracy score is printed out for evaluation. The concept behind this code implementation in machine learning is crucial for model evaluation and performance optimization. Cross-validation helps in validating a model's generalization capability as it assesses the model across multiple data subsets. This enables a more robust understanding of the model's performance and helps in detecting issues like overfitting. An example of a real-world application for cross-validation techniques is in medical diagnosis. By utilizing cross-validation, a machine learning model can be systematically evaluated on different patient datasets to ensure its accuracy and reliability in predicting medical conditions. One real-world application of cross-validation techniques can be found in the field of credit scoring. When building a credit scoring model to assess the creditworthiness of individuals applying for loans, it is crucial to ensure that the model's performance is robust and generalizes well to unseen data. By utilizing cross-validation techniques such as k-fold cross-validation, data scientists can evaluate the model's accuracy, precision, and recall across multiple folds, thus providing a more comprehensive assessment of the model's performance. Another industrial application of cross-validation techniques is in algorithmic trading. When developing trading strategies based on machine learning models, it is essential to assess the model's predictive power and stability. Cross-validation can help in evaluating the trading strategy's performance across different time periods or market conditions, thus reducing the risk of overfitting and ensuring that the model performs well in real-world scenarios. Across the globe, industries leverage cross-validation techniques to enhance the robustness and reliability of machine learning models, leading to more accurate predictions and informed decision-making. Keep learning, stay curious, and I'll catch you in the next video.